Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually discussing the third chapter of science subject in 9th standard, that is atoms and molecules. So in that particular video, I actually discussed what do you mean by law of conservation of mass, what do you mean by law of definite proportions, and I also discussed Dalton's atomic theory, and I also discussed the 6 postulates of Dalton's atomic theory. So in this particular video, we will see the further concepts which are there in this particular chapter. So now we have discussed so many things about atom in Dalton's atomic theory in my previous video. So atoms are basically building blocks of any matter. So if you observe a building, so this particular building is made up of small bricks like this. So when bricks are actually arranged in a proper manner like this, a strong building can be constructed. Similarly, to construct any kind of matter, the atoms will act as the building block of that particular matter. So these atoms arranged together in a specific manner with specific bond, and hence they form a particular matter. So basically atoms acts as the building blocks of a particular matter. Just like brick pieces are very small in size, when you go on arranging that bricks, you will form a very big house or a building. So similarly, to get a very big matter or any matter which you can see around you are all made up of atoms. So atoms are building blocks of any matter, for example. So now you might be wondering how big these particular atoms are. So atoms are in the scale of nanometer. So what do you mean by nanometer? 10 power minus 9 meter can be known as nanometer. So what do you mean by 10 power minus 9? So 10 power minus 9 means 0.000000001. So this actually accounts for 10 power minus 9. So how to convert this particular 0.000000001 meter into 10 power minus 9? So you will move this particular decimal point to this particular place, that is after 1. So you are actually moving 1, 2, 3, 4, 5, 6, 7, 8, 9. So after 9 digits, you are actually moving this particular decimal point. So when you are moving that particular decimal point to your right hand side, so at that particular time, you should actually put negative symbol in the power of 10. And after how many digits you are moving that decimal point, that number should be put in the power. That is 9. So 10 power 9. Since we have moved that to a right hand side direction, the decimal point has got moved to right hand side direction, you will put minus. So this particular 10 power minus 9 is known as nano, and this meter is anyway there here. So 10 power minus 9 meter is nothing but 1 nanometer. So 1 nanometer means it is 1 into 10 power minus 9 meter. So now if you consider the smallest atomic number element, that is hydrogen, so the radius of hydrogen atom, so this is actually the radius of hydrogen atom. So radius of hydrogen atom is 10 power minus 10 meter, and this particular 10 power minus 10 meter can be written as 0.1 nanometer. So how can you write 0.1 nanometer? Because 10 power minus 10 is nothing but 10 power minus 1 minus 9. So this you can write it as 10 power minus 1 into 10 power minus 9 according to law of exponents. This also I have actually discussed in the exponent chapter in 8th standard mathematics. You can refer that particular video. So 10 power minus 1 into 10 power minus 9 is there. What do you mean by 10 power minus 1? 10 power minus 1 is nothing but 0.1, because when you shift this point to the right hand side of this particular 1, then you will actually see 1 into 10 power minus 1 you will be getting. So 10 power minus 1 can be written as 0.1, and 10 power minus 9 can be known as nano, and the symbol for nano is small n, and meter will be there. So 0.1 nanometer or 10 power minus 10 meter is the radius of this particular hydrogen atom. So radius of water molecule. So now when you take radius of a particular water molecule, so in water molecule you will be having H2O as your molecule. So this particular H2O molecule will have approximately in the range of 10 power minus 9 meter, that is 1 nanometer. So this is the radius of this particular water molecule. So this is an approximate measurement of the radius of water molecule. So you all know that in blood there will be a component called hemoglobin. So radius of this particular hemoglobin will be in the range of 10 power minus 8 meter, or you can call this as 10 nanometer. So radius of a grain of a sand. So if you take one grain of sand, then radius of that particular grain of sand will be in the range of 10 power minus 4 meter. So now what is the radius of an ant? So radius of an ant, approximately it is in the range of 10 power minus 3 meter. So now what might be the radius of apple? So radius of apple will be in the range of 10 power minus 1 meter. That is approximately 10 centimeter. These are all not fixed values for the radius of these particular objects. These are all just an approximate values of radius of these particular objects. And you should remember one thing, that all these particular objects are made up of atoms. That is the building block of every single object which you are actually seeing around you. So first, when Dalton came up with his Dalton's atomic theory, he actually gave some symbols for very commonly known atoms. For example, this was the symbol which he actually gave for hydrogen. So if there is a dot inside a circle, then this particular symbol represents hydrogen atom. So if there is a Y written in a reverse manner inside a particular circle, then this particular symbol is example for phosphorus atom. So now if you write C inside a circle, then this particular symbol represents copper atom. So now inside a circle, if you write G and there is small spikes in this particular circle like this, then this particular symbol represents gold. So inside a circle, if there is a light gray colored shading, then this particular symbol can be known as carbon atom. So if there is a plus mark inside a circle, then this is actually known as sulfur. So if you write L inside a circle, then this particular symbol represents lead atom. If there is P written in this particular circle, then it is actually represented as platina atom. So all these symbols were actually given by the scientist Dalton. So all these symbols are relevant to that particular period of time when Dalton gave this particular symbols. So just if you write an empty circle, then this represents oxygen atom. Similarly, if you write I inside this particular circle, then it actually represents iron atom. Similarly, if you write S in this particular circle, then it actually represents silver atom. So now if you write small dots in a particular circle in this particular fashion, then this actually represents mercury. So these were all common symbols given by Dalton for various atoms. Initially, the name for a particular elements were given based on from where they were actually obtained. The name of that particular place were kept for few elements. So for example, if you take copper, this particular copper was first actually obtained in a city called Cyprus. So this particular name of the city, that is Cyprus, was used to name this particular element copper. Sometimes even the appearance of that particular element gave the name for that particular element as well. For example, gold. So in English, gold means yellow color. Because gold was very much yellowish in color, this particular name gold was kept for this element gold. So like this, based on the origin of that particular element and also based on the appearance of that particular element, various names were given for different elements which are there in periodic table. This is a scientific organization which actually decides the nomenclature of elements and also the nomenclature of different compounds. So whatever compounds, whatever elements are there in this particular nature, all those compounds, elements are actually given a particular IUPAC name. So this particular nomenclature is actually done by this particular scientific organization, which is named as International Union of Pure and Applied Chemistry. And in most of the elements in periodic table, the symbol of that particular element is given as the starting letter of that particular element. For example, if you consider hydrogen as your example, symbol of this particular hydrogen was given as capital H. So any element, if you are considering, not all the elements, most of the elements in periodic table have their symbols as the first letter of that particular element name, or in some cases even first two letters of that particular element is also considered. For example, cobalt. The symbol of cobalt is capital C and small o. So why the second letter, if you are taking from a particular element, then that particular letter should be small and the first letter will be capital. This is applicable for few elements in the periodic table, and few elements have just single letter, that is the starting letter of the name of that particular element. There are certain exceptions in these particular elements as well. For example, if we consider sodium, sodium has Na as its symbol. Here S is not the symbol of this particular sodium, and O is also not considered, or SO is also not considered as the symbol of this particular element. So here the symbol of element is not S, and also symbol of element is not S small o. No. Why? So if we see the example of previous element, here hydrogen has H as its symbol and cobalt as CO as its symbol. But sodium doesn't have S as its symbol, and also sodium doesn't have SO as its symbol. But sodium has Na as its symbol. Because the name of this particular sodium was natrium in the olden days, hence this particular Na is actually taken for this particular sodium as its symbol. So like this, there are few exceptions in the periodic table. Sulfur was given S, and sodium, for sodium they considered natrium as its name, that is the old name of this particular sodium, and they used Na as the symbol of this particular sodium. So this name is actually derived from the language Latin. So in Latin language, sodium is referred as natrium. So here they are actually taking help of this particular Latin language and in some cases Greek language for that particular elements, and that particular starting letter of the word which is there in Latin or Greek is actually considered as the symbol of that particular element. So here for sodium, natrium is the Latin word and Na is the starting letter of this particular, starting letters of this particular natrium. So that's why that Na was kept as the symbol for this particular sodium. The further concepts which are there in this particular chapter will be explained in subsequent videos. So like this, if you want to learn more physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.